So in terms of your strategies, first thing I would recommend is recognizing that this is an exponential equation. So then you can pick which of these methods it is. Which one would you call it? Yeah, it's the third one, right? Variables on both sides, and you can't get a same base. So we're going to take natural log of both sides. Or you could do log, just common log if you want. And then that allows us to bring those exponents out front as coefficients instead. This left one needs parentheses. The right one is okay without. Now what? Yeah. I will tell you, there is a way to do this by dividing by x and then dividing by natural log of 3. Because that creates a fraction, I sort of think you probably shouldn't, but you can. So just distribute instead. And because this always works, that other method doesn't always necessarily work. Okay. So we need to bring these x's together, and I think I'll probably move it to the right so that I only have to move something once. Otherwise I'd have to move something. Well, move this and then also the natural log of 3. So I'm having trouble writing. Can you combine these in any way? Okay. Yeah, so it's not like x minus x equals 0 or something. But we can factor the x off. And why do we do that? Like, what good does it do to do that? Did you say the same?
Yeah.
Okay. And what was it? Yeah.
It's away from it.
Yeah, it allows us to separate the x, so what you're saying is true. Okay? Then we just divide. And you'll see, I think you have already, actually, because people were asking me about this yesterday, but you'll see directions that say give the answer to the nearest 10,000th or something. This is solved, okay? And certainly, if you ever take AP classes, that's an okay answer. You don't actually have to keep going to give a decimal in most cases. But it is also good to be able to do this on your calculator and work through all the parentheses that I showed you yesterday. So, how many of you feel confident with that step, with the last step? Parentheses galore. Okay. How'd you do? Did you get to that point? Okay. One question that I'm seeing as I'm looking at work, is it okay to do that? No.
No.
So don't, because of this subtraction, that is not an okay step to take. Now, you could, well, never mind. There's nothing you can do beyond that, so let's just leave it at that. Well, let's check homework and then you can ask questions. So you started on 16. Give you a second to pull that out so you can check your work. So 16, you should have gotten 1. 17.6833 is if you did the decimal. If we need to go back and see what those look like as a non-simplified log, we can. But number 18, you have 2 answers, negative 1.5 and 3. And that was because of a quadratic. 19 was negative 0.4286. 20 was 6. 21, 5. 22, 1.4406. 23, 4.5101. 24, negative 0.5638. 25, negative 3.1699. 26, 4.0643. 27 is 7. 28 is about 9%. How'd those go?
Good.
Sure. Can't really tell. Do we need to do one? Any that you'd like to do?
You do 17.
17, okay.
No, 26.
Well, we can do both.
No.
We'll start with 17. And what was the other one? 26?
Yeah.
Okay.
So we did 28 too.
Yep. All right, 17. So we have variable on just one side. And so the best way to do that is just log. Which log? Yeah. Well, if you have your graphing calculator, you can do log base 7 of both sides. And if not, you can still do, I'll write it separately actually after this one. So those cancel, and then we just get 3x equals some number. Log base 7 of 54 is like 2 point something. So 2 point something. And then just divide by 3. Okay? Is that helpful enough?
Yeah.
The other way you could do this one, if you want, is to log, either log or natural log both sides. Then you can bring your 3x out front. And then divide by 3 natural log of 7. So 3 times x times natural log, you can just move the 3 over with the natural log of 7. That's totally fine. Anyway, both of those give you the same answer. Even though it doesn't really look like it should, but it does. Okay. All right, 26. 26. So this is like our warm-up, where we have variables on both sides, and we can't get a common base. So I'm going to skip a step, but we'll log or natural log both sides. So I've just pulled the exponents out front already. Okay, and then we get 2x natural log of 3 minus 3 natural log of 3. And then we need to get these x terms together. So I'm going to leave the negative 3 natural log 3 there. Okay, now what? Yep, so factor off your x. And leave the 2 left behind with the natural log of 3. Okay, and then we just divide. So and 28, right, honey?
Yeah.
Okay. Any questions on that one though before we do 28? Oh, I could probably do that one right here, I guess. All right, Dale has $1,000 to invest, and he wants to have $2,500 in his investment in 10 years. So we're solving for the rate, the interest rate, and we're compounding continuously, which actually changes this problem a fair bit to say continuous versus like monthly. I'll show you what I mean at the end. So how do we set this up? This time we have to write our own equation. So he wants 2,500 starting with 1,000. So we're using the B equals PR PE to the RT. Okay, and this time we don't know R, but we do know T. So sometimes it's the other way around. But either way, you have to get rid of E, right? To get either R or T out of the exponent. Okay, so we'll divide by 1,000 first. What is 2,500 divided by 1,000? And I'm just going to reverse those so it looks more normal. How do you get rid of E? Yeah. I mean, you can natural log these anyway, but in this case, it actually cancels the E. So we're a step ahead in this case. Okay, natural log of 2.5. That's really close to 1. And then just divide by 10. So it's just barely under 1. So, not 1. What did I say? 1/10. So the answer, that was 28, 9.16%, so just under 10%. Okay? Anyway, did that help?
Yeah, thank you.
Okay, any others? 18, okay. Oh, you know what, before I do 18, I was going to say, think about how this would change if this said compounded monthly. So this would still, all these beginning numbers would look the same. But what would go in here now if it was compounded monthly?
One minus,
Not minus.
or what?
Plus R over 12 to the 12 times 10. Okay? How is that a different problem than what we just did?
It's not compounded continuously.
Well, I know. I don't want the obvious answer. How are you going to solve that for R? It's actually a completely different process than what we just did, even though it's very similar in terms of the structure of the problem. And you do need to know how to do both. What are we trying to get rid of this time? Like over here, we wanted to get R out of the exponent. R is not in the exponent this time. So, sorry, what? We have to get that 120 exponent off. How do you get rid of a 120 exponent? Say it. Well, she's doing this. You guys remember what it's called? It's a root, yeah, or a radical. Which one? Can I square root this? So which root? Yeah, the 1/20th power or the 120th root. Okay? I think I'll just leave that much. Okay, so if we take the 120th root, that undoes a 120th power. Now we can get R out of that side. That's a different process than logging, right? Okay. All right, back to 18. And I'm glad someone asked about one of these. I think sometimes people miss that you can do this, so it's good to keep it fresh. What's the strategy on this one? What is the best strategy? There's not just one strategy, but there is a better one.
It powers 5 and then multiply.
Yeah, so look at this is 5 squared, so the x squared, and this is 5 cubed, so the x plus 3, And then what do we do with the 2 and x squared and 3 and x plus 3? And we can drop them at the same time, drop the bases I mean at the same time. So 2x squared equals 3x plus 9. And then hopefully you recognize right away that that is a what kind of equation? Quadratic. So these guys were asking before most of you came in, oh I think it was them, isn't it just the second semester on your final? And I said kind of, okay? We didn't do quadratics in the second semester, we did that at first, but that's a skill you need to know forever, okay? So it will be on there, you'll need to know how to factor and solve. You guys remember quadratic formula? Just in case, I'm not saying you'll need it, but okay. How would you do this one? I mean, we might as well try to factor this, but we have to get it set equal to 0 first. Okay, so set up the star. A times C is negative 18. And then B is negative 3. A, of course, is 2. Are there factors of negative 18 that add up to negative 3?
Negative 16.
Okay, and then I could see this getting missed. What should you do with that right there? Yeah, don't forget to reduce those sides. That's more critical for factoring than solving, but since you might need to do both, it's good to just always do it. Okay, so that becomes x minus 3, and over here 2x plus 3. And then there's our x equals 3, and then this one is our x equals negative 3 halves, which is negative 1.5. Henry, did that help? Okay. I will tell you, you need to be able to do that process on your final for sure. Come from an exponential to a quadratic to a solution, etc. How do you feel about solving exponentials? Give me a fist of 5. Okay, looking good mostly. What was yours? Just to give you a heads up, your test looks like this. So the first page, first front back is no calculator. You'll have some key features questions, then condensing and expanding. So using log properties to expand or condense logs. And then inverses, which is essentially solving. And then all of this kind of stuff will be on the calculator section. So not that it always helps, but at least it's on that. And it does have word problems too, a few of them. Examples. I think what we'll do is put one in of each kind. Alright, we're moving on, let's go. You kind of have an example of what 29 looks like, but I'll still put one in there. And then we could do one like 35 or 37, those kind. Let me go grab one. Okay, I will give you this heads up though. There is an additional step to solving log equations that you didn't have to take with exponential. Anybody know what I'm talking about? Okay, I'm going to give you a hint. Is it okay to have a negative inside of a log? Okay. So what do we call that if one of our solutions, or maybe both, don't work? What do we call it? Last unit we had to check for this. It starts with an E. What did you say?
I didn't hear what you said.
Oh, I said, what do we call it when maybe one or both of our solutions that we solve for don't actually work? You guys remember that word? Starts with an E.
What's the
E.
next one?
X.
Exponential.
X.
No. EXTR, ends in Eneas.
Extraneous.
Alright.
I've never heard you
Yeah, no.
Extraneous?
say that. I don't remember saying that.
Yeah, we did. But remember in the last unit we had to make sure the denominator wasn't 0?
Oh.
So if it was, that was extraneous. Okay. Alright. Here's how we'll break this up. This type is 1 log on each side.
Brother.
Do that. You write the title.
I give you a whole like 2 minutes to leave it.
What's the problem?
Because you,
You
always write the
always
equation
write
and then you're like,
something,
oh, we're gonna put a
Erase
title
it,
now.
remove it.
Oh. Alright, well,
Yeah.
sorry.
I'm sorry about that. We're just we're joking.
Okay. So this one you should know how to solve. I just need to remind you that you have to check for an extraneous solution. But how would you solve it? When there's only 1 log on both sides. In this case, they have the same base. Yeah. Yep. So this is kind of like what we already wrote earlier in the notes. So we're going to do, and remember, if you, never mind. Right. The steps, the description of the steps on this is a little short because that step is kind of the main one. You take the base to the log power and then the logs are gone. And you're dealing maybe with a quadratic like this one or maybe a linear. And then you just solve like normal from there. But step 3 is going to be our extraneous check. You can draw the star if you want to. But what are our factors going to be? Can you do this one in your head? Factors of negative 45 add up to negative 4. Negative 9 and 5, right? So x minus 9, x plus 5. Which gives us what in terms of answers? Those are not complete. Okay. So don't stop there. So we're checking for extraneous solutions. Here's how. Check the inside of each log is not negative. If it's negative, kick it out. Does that happen with this one? Like, do we have a negative argument. Remember the thing inside of the log is called an argument? Well, just check both. Does 9 cause any issues? You know what, by the way? Not negative or 0. We do need to say that. Glad I didn't forget that. Anyway, 9 squared minus 45, no issues there. On the other side, 4 times 9, no issues there. Both of those are positive, safe, right? Okay, but if I plug in negative 5, both of these in this case are negative, because that would be 25 minus 45, which is negative 20, and over here negative 20 as well. So that doesn't work. So x equals negative 5. This is extraneous. I'll do that better. So your only solution is 9. Is it possible to have no solution in these? Think about if we had some situation where a quadratic solved to both negative answers. We've had that before. Then neither one would work. And also you might run into cases where you don't have extraneous solutions, like both of them do work. So you do need to check. Any questions on that one? The solving part was kind of normal. Let's do an example where it's a little less normal. You want me to write the problem and then the title? Or do the title first?
Title.
Okay. Actually, let's add to that title too. Well, I'm thinking of trying to capture everything for you. More than one log on either side, or if like the one I showed you a bit ago that had that 4 stuck at the end. Or a random constant. We can do 2 more examples if you want. Or just this one, and hopefully you can extrapolate that to other circumstances. What do you think? I'll come back to this, don't worry, but I just want to show you what I mean. If you look at these 2 problems, which one looks harder? The bottom one or 36? Okay. I think probably students would struggle with 36 more than 37 actually, depending how you think to apply this example we're about to do. So let's do one like 37 and then you can tell me if you feel like you need a different one. Okay? Alright, there's your problem. Go ahead and get that written. That was a little step. And actually, the first step is only difference between this and the previous one. Otherwise, we're just going to write C above steps to finish. But first step, what do you guys think you should do? Any thoughts?
Move the
Base log. Get rid of the logs.
Move those up.
Get rid of the logs.
Well, okay. Hear this, because this is probably the most common mistake. Can you do, don't write this, just listen. Can you do this? All those are log base 3, can you do that?
No.
Why not? Okay. Well, over here we're taking 3 to the entire side, not adding 2 different ones. Okay? So it's an order of operations thing. So we can't do that. But we can combine these 2 into one log. Then we can do that part. Okay? So our first step is use log properties. To combine logs. Combine means either condense, which is the more usual. And you're not going to ever expand, so just condense. So the left side is fine. I don't need to do anything with it. What does the right side become?
And then is it like the X over, or is it actually?
Well, what happens? Okay, so think about your log property. Which property creates plus when you use it? Multiplication. So if we're going backwards, those need to be what? Multiplied together. Is that what you meant? Okay, so that addition tells you it was multiplication property so that we can put it back into a product. Okay, what would you do from here? Yeah, now you just follow the steps that we just wrote. Good. Okay. So this is going to look like, not that. You guys are hyper today.
Maybe you're incompetent.
Oh, pretty much that way. How would you solve that one from there? We are done with current unit stuff, meaning logs are gone. Yep. What kind of function are you going to have when you distribute? Okay, so we want to get this set equal to 0. Plus 2x minus 1. What's wow?
Huh?
What is wow?
Oh, it was, no, not.
Okay. Alright, look at that one. Can you factor it? So here's your question. Are there factor 2 times negative 1? Are there factors of negative 2 that add up to positive 2? What are the factors of negative 2? 1 and 2. Those don't add up to 2, right? So what are you going to do?
No.
Extraneous. No.
We're not there. We don't have solutions yet. Good job, Leah.
Bar is me off.
Anybody have it programmed into their calculator?
What's the first letter?
The first thing you write is the negative sign,
Huh?
but then it's negative b.
Negative b
Over 2a. Do we need to rewrite it?
Yes.
What goes on the other side of the equal signs before all that stuff? Like, what are we actually solving for? Yeah, x intercepts. There's that.
Oh, that one.
Use your calculator. He's got it. Do you?
I don't know what we're talking about yet.
What other?
The other two.
There's so many of them.
Nobody's doing it. You're just sitting here looking at it.
Oh,
I
really?
do. I'm great. I'm doing something.
Alright, we're gonna do this once. Ready?
We have x equals -1 minus square root of 3 divided by 2, and x equals -1 plus square root of 3 divided by 2.
Okay, but let's get some decimals for those.
There's no
Or
answer.
x equals -1.36, and x equals 0.36.
Okay, there's your two x values. What's our last step?
Let's see which ones are real.
Okay, now everybody chill for a second and look here, please. Listen. Do you see how this time we need to check this negative in all three places? If it makes even one of those negative, we have to kick it out. Okay? Do we need to check the positive one? Yeah, you do. Because what if one of these, like, what if this said minus something that made this negative, right? So yeah, you need to check the positive ones as well. It turns out in this case, the positive one is fine. You can look because all of them are plus or just x, so the positive one works. But how about the negative one? As soon as you plug it right there, it's negative, and therefore it doesn't work. Even though it does work in both of these. Okay? So even though it works in 2 out of the 3, it's still extraneous. So it goes away. Alright. Last, I don't want to put this in here. I decided I'm not going to do that, but I'll show you real quick. If you want to just think through it with me. How would you do one like that with the constant stuck at the end? Or perhaps it's on both sides. I mean, it doesn't really matter. Say it again. No. That would be nice, but we can't just ignore the 6.
Why?
Well, you just can't do it. The steps that you would do in the meantime would throw off the answer.
No, but don't you have to do something else first?
Can I do 5 to the and get rid of all of it? No, because of that plus sign right there would throw it off.
Oh, because that's one. Oh, okay.
What do you do? This is why I said students struggle with this kind of.
Can you
Okay.
just erase
Combine
the X
what?
Or the
1 base 5 and 2x minus 7 and plus 6.
Okay. Listen, she's got the right idea. I don't have to combine these on just the one side. If I subtract over here, can't I still combine that?
Yeah.
That is log of a difference, which becomes a what? Division or quotient, right? So it becomes log base 5 of 3x plus 1 over 2x minus 7. And then that 6 just hangs out by itself over there for a bit. Now what?
That's solved.
It's,
There you go. You're all done.
you should work with Lena. He's got this. Okay, we get rid of the log like normal. Okay? I should go back and see if there's one of these on the test. Is 5 to the 6 big or small?
Big.
It's pretty good size. How would you solve from there? You remember how to solve a rational equation?
Give me a hint.
Well, okay. Think of it this way. What's 5?
I'll give you this hint.
I didn't onion. Yeah. I heard rational.
Make it into a
A butterfly.
proportion. Yeah.
Butterfly method.
Right, I'm not talking about it anymore after that.